Hi, everyone. Welcome back to the second episode of Live from Case Done by AI. My name is Benz. I'm your host today. I would like to present to you what we have in the world of AI, especially generative AI, where it's been making buzzes nonstop since last year. And this is where at Case Done, we would like to bring all the knowledge and excitement and all the possibilities to you. Let's get started. So I think everyone has probably heard about the biggest announcement that happened this week or last week. It's OpenAI has announced its text to video generation model called SORA. So according to its website, as you can see here, it says that it can generate video from text and it's realistic and imaginative. And I've actually gone through some examples on that website, and it's actually pretty mind-blowing thing. For example, this is the video that is generated by SORA AI, and you can see that it's very, very realistic. And it's only this prompt that you need to make in order to make this video. So the prompt is saying a movie trailer is a movie trailer, right? But featuring the adventure of the 30-year-old man, 30-year-old spaceman wearing a red wool knit motorcycle helmet, blue sky, salt desert cinematic style, shot on 35mm film, vivid colors. It looks pretty good. Like it matches the prompt. So let's actually go into SORA website and see all the details that they have. Okay, this is the website from OpenAI. You can go there yourself after this, openai.com/SORA. And according to this says all the video in this page were generated directly by SORA without modification. I think this is funny because if you remember last year in December, that was a big buzz because Google released what they call the Gemini models. And during that time, it was created such a hype, but then we figured it out that all the presentations that Google made were actually modified. So the model is not at that state of capability yet, but Google team has made itself in such a way that it's so advanced. So this is maybe like some sarcastic comments to Google. So all of the videos that you will see on this page has not been modified at all. Let's take a look at this. So again, SORA is a text to video model. It can generate video up to 1 minute long. And OpenAI says that it has very good visual quality, and it sticks to the user's prompt. Let's go to this example. So this example is like what? Stylish woman walks down Tokyo street filled with warm, glowing neon. Oh yeah, this is glowing neon right there. And animated city signage. Yes, you can see a lot of city signage on the background there. And she's wearing what? Black leather jacket, a long red dress, and black boots. Some more detail. And carries a black purse, wear sunglasses. Yes. Red lipstick. Yes. She walks confidently. I think so. Casually, probably yes too. The street is damp. Oh yeah, definitely damp and reflective, creating some mirror effects of colorful light. Pedestrians, many pedestrians. I don't see that many, but I think it's not that bad. Let's see, go to the next one. This one is several giant woolly mammoths. Wow, okay. So we don't have mammoths in real life, but you know, you can do like computer graphic generation, but this looks pretty good. So it's walking on the snow meadow. Their long woolly fur lightly blow. Is it lightly blow? Probably. Mid-afternoon light. Sun high on distance. I think so. Low camera view. So you can specify the viewing angle of your camera as well. I think this is a pretty good quality. Okay, we have seen this one. Okay, wow, it looks like a drone footage, is it? Right there. A drone view of waves crashing against rugged cliffs along Big Sur Garrier Point Beach. Wow. Okay, so drone has just been popularized maybe like in the last 5 to 10 years or so. I guess there are a lot of footage for OpenAI to use it to train the model. And this is actually good quality. You can see all the waves and the tiny details, the bubbles that the waves created. Looks amazing. Okay, this is more like animation to me, right? Animated scene features a close-up of short, fluffy monster kneeling. Is it kneeling? I don't know, maybe. Beside a melting red candle. So on spot there, all the subject in the scene is there. Uh, the style is 3D and realistic. It's actually pretty good. Wow, I think like Disney will probably use this technology somehow in the future, I guess. Well, okay, this is what I'm guessing. Focusing on light and texture, I think it looks really amazing. What is this thing? Gorgeously rendered papercraft. Oh, this is papercraft world of coral reef. Oh wow. Okay, so this is style, right? OpenAI is showing that it can generate movies with different styles. We have seen animation before, but now we specified it to be papercraft style of animation. What is this one? This one is about a close-up shot of Victoria crowd pigeon. Okay, I don't think there's anything interesting for me right here. I just skip this. What do we have here? Oh wow, this is cool. A photorealistic close-up of two pirate ships battling each other, but looks like in a cup of coffee. Okay, that is pretty cool. So you can see that the quality of the videos that are generated by Sora is actually pretty high quality, cinematic or high quality animation. So I think that's why the whole world is going crazy about Sora right now. So the Sora now is in the stage of what they call it, uh, red teaming stage. It's a team that actually checks for harms and risks that the model can actually do. I can think of a few things like scenes about murdering people, maybe, or even like some pornography. Probably not the purpose of OpenAI model for sure. I think this team is going through check if the Sora model is actually doing the thing that they don't want it to do. Okay, so we have more AI capabilities on the horizon there. So this footage is meant to be historical of California during the gold rush. I think it's pretty cool there. Wow, look at that. So think about it. If you want to make a cinematic scene that looks real, you don't need to actually build all these stuff anymore. It saves a lot of money, right? You just need to spend some money on electricity power that power the AI, but you can actually do something real like this. What is this thing? This is a close-up view of a glass sphere that has a Zen garden within it. Right, pretty cute. Oh wow, okay. Extreme close-up of 24-year-old woman blinking, standing in Marrakesh during a magic hour. I don't know where that is. Cinematic film shot in 70mm depth of field. Actually, that is pretty good depth of field there. I think the camera tries to focus on the surface of the eye, and the rest forward and backward should be blurred. And you can see the nose is blurred there, and the temple and the ear is blurred as well. So it's actually pretty good. It understands the words depth of field. Okay, this is some animation. This is some beautiful generation of people in Lagos, Nigeria, in year 2055, 56. Okay, pretty good. Good imagination, I guess. This is about, what is happening here? A petri dish with a bamboo forest growing within it has tiny red pandas running around. Okay, this probably, I guess this is a glitch. This is unexpected. So maybe intended, but too many red pandas like popping out of nowhere. Okay, it's kind of funny. Okay, what is this thing? It's a camera rotates around a large stack of vintage televisions. Or most of the kids probably don't know that, like, back in the old days, cameras is not flat, camera is not that wide, it's pretty fat. Before we use what we call a cathode ray engine there. So I don't want to go into the detail of how it works, but you need some space to project the image there. Looks pretty cool. This is like vintage televisions that show different programs. Okay, most of these programs I don't know. It's probably dated back before I was born. Okay, animation. All right. So now it's selling that Sora is capable of generating complex scenes with multiple characters, specific types of motion, and accurate details of specific of the subject and background. This one is about around a truck, I think SUV truck, SUV car is driving. So you can see all the physics here. It's pretty interesting that it can generate dust clouds because the car is driving on dusty roads. Good physics there. This one is pretty cool. Look at this. The prompt is reflections in the window of a train traveling through the Tokyo suburbs. This is actually pretty nice. I'm really impressed how they can pull it off. Drone footage, maybe not that interesting to me. This one is, what is it? Orange octopus resting at the bottom of the ocean floor. Not resting, being chased by a giant crab. But actually crab, isn't it like the octopus food or something? Anyhow, looks pretty good. This one is a flock of paper airplanes flutters through a dense jungle. Pretty nice here. Okay, for cat lovers, you can have it too. You can generate your own videos of your beloved cat. This one is a cat waking up its owner, demanding breakfast. So most of you are familiar with this situation. The owner, the lady, is trying to ignore the cat, but I don't think she succeeded eventually. All right, lots of birds. Okay. Now, the model has deep understanding of language. This is because in the actual paper, the developer of Sora actually coupled the fusion model with GPT models. So for each of the image frame, they have to generate a very high quality caption for that image, and then feed the image and generate a caption to the model to learn. And in order to have a quality understanding of human needs, the caption needs to be in detail and high quality. And they actually use the GPT model to help them fill the gap there. So you can see a lot of very impressive details. Like this is like a tour of the art gallery with many beautiful arts. Actually don't know if these are actual artworks in the museum or not, but from the look of it, I can't really tell. Expert can maybe. This one is painting a journey in a snowy day in Tokyo, I think. Looks pretty realistic to me. Very, very good. This one is flower blooming. Nice. This looks like some game trailer maybe. Could be a story of a robot's life in a cyberpunk setting. Cyberpunk is a game. Okay, close up. Good. So Sora model can understand what you need. That's what the OpenAI team wants you to know. It can follow your prompt really, really well, understand the complexity of the situation, so that it can generate the video that you want. What I like about this is that it actually, the OpenAI team acknowledged the weakness. And some of the weakness we see is that it doesn't really understand some physics. Like maybe people will do that. I'm not sure. Like, are you going to run or walk on your treadmill backward like that? This one is, look at that. You have, oh, I'll start with 3. Now you have probably like 100 of the baby wolves right there. So it doesn't, for this one, I think it kind of lost count of how many puppies are there to begin with. So this one is inaccurate physics modeling and unnatural object morphing. Oh, explosion, really? Okay, and like now you have a duplicate of the basketball. That's really cool. That's kind of funny though. Okay, what is happening? Oh, okay, it comes out of nowhere. Okay, see, so it's the model still has some weakness, but I think for most of the time, if the model is actually out for the public to use, probably going to be really fun to use it. I'm curious what's happening here. Can you see? Can you guys see what is happening? Okay, the flame didn't move at all when the lady just blew it. So the physics is not there yet. I think they will probably improve it pretty soon. For this one, it's about safety. So essentially, OpenAI wants to implement a safety net where videos that are generated by SORA models will be actually detectable by some kind of method that is invincible to the viewers. For example, they probably going to use what they call like C2PA metadata that they already have in DAO 3, but it will be incorporated somehow into the SORA model. So you know what? I think all in all, I really like the result that the OpenAI team has come up with. It's very mind-blowing thing to see, and no wonder it has like make a big buzz in the past few days. You can go into this website, OpenAI website, to take a look, read all of this stuff again, and you know what? This is text to video generation model, and I really like how they actually do make the website. Look at that. This is the end of the presentation, and what does it look like? It actually looks like a movie, isn't it? That's pretty cool. They actually think in the all round. All right, 360, right? Okay. Now we have seen SORA in detail. So to summarize all the points there, right now, SORA can generate video up to 1 minute long, high quality. As of February, it's still being probed for harms and risk, but I'm excited to have my hands on it when they actually like release it for the public. Oh, typo safety. Some kind of watermarking, it should be there. Actually, I'm not sure if most of you have heard about Lumiere, but 2 weeks ago, Google, at the same time as they rolled out Gemini to replace Bard, they actually launched a text-to-video generation model called Lumiere. So I want to take a look. I want to show you how this Lumiere technology to SORA. So it can high quality. They say high quality text to image generation. Oh, sorry. Oh, some glitch. They say it's high quality. Look at that. Does it look like high quality to me? Not that much, I guess. They also have other features that they advertise that they can do image to video. You don't need to start from text to create the video, but this is something that SORA can do as well, right? So actually, let's go to its website to actually see all of their Lumiere capability. So text to video generation, image to video generation. You start with the image, it will create a video. I don't think this is that mind-blowing just yet. Stylized generation. You can specify the style that you want. This is nothing new as well. This is some technical details of how the model is generated, its architecture and stuff. Video stylization, nothing that particularly interesting or mind-blowing or new. Cinema graphs. So this is more like you give it an image, you mask the area you want it to be in motion, and then it will generate such a thing. I think I've seen SORA model does this as well. So the model is kind of like competing. In painting is where you mask off the area and you want the model to fill in the gap. For example, like this, like balloon thing, you mask this area and the model kind of fill in the gap, right? This is one of the example as well. I don't know what that was before, but now it's some kind of cake. So all in all, the Lumiere models from Google has all these capabilities. But to me, they are based on similar method, maybe different in some major details, but they're both transformers. But the idea is, just let's dig into it a little bit deeper. For the large language model, it's a language model. What they do is that they break down all the text into words. They focus on words. More specifically, sometimes they focus on subwords. So essentially, they are breaking a long sentence into manageable bits called tokens. They apply the same idea to videos. They break videos into a series of frames, similar to a series of words or tokens, and each frame of the video can then be broken down subsequently into sub tokens, I guess. So this is what they are doing right here in this the latest version of AI models for text to video generation. A very clear example is actually presented in Google's website Lumiere. As you can see here, you have fed in. You will feed in a video, and it will be broken down, actually suppressed or compressed first, and then broken down into series of tokens for the model to learn. This is the underlying idea of how to train this kind of model. Okay, for verdict, if I had to choose between SORA or Lumiere to create my, for example, advertising video for case done by AI, what am I going to do? What am I going to use? I think for now, I have to give it to SORA. I think I'm very, very impressed with its capability, and it's actually high quality as opposed to what I've seen with Lumiere. But Google, fight! I think you will come up with something better, at least better than Lumiere soon. Okay, for the next part of today's live episode, let's switch to Google a little bit. I don't want to like ignore it because I think they are doing something good. So today we are going to talk about Gemini. Google has announced that now we are living in the era of Gemini models. And what I find useful, and not just me, I think it's like Andrew Ng, an expert in AI, talked about this as well. He mentioned that we can use large language model or LLM as a reasoning engine for your business. In this table, what I'm showing you is the capability of the Gemini large language model in comparison to the GPT-4 models from OpenAI. I don't want to actually compare them, but I want you to go see that these models have been evaluated for their reasoning capabilities. In this table, there are 3 types of data sets to test the LLM's reasoning capability. You don't need to know what they are, but essentially the LLM models that will be created in the future. And it will be used for something like a ChatGPT or Gemini kind of / Bard needs to be tested for reasoning capability, because people will now use it. The general public will probably use it more and more. I will give you an example here of the data set called Hello Swag. To summarize, this is a data set to test for common sense reasoning in everyday tasks that the models will need to be evaluated on. So what is it? What is the Hello Swag data set? It stands for harder endings, longer context, and low shot activities for situation with adversarial generations. It has no meanings for commoners like me, but it's a data set. I'll try to explain it. It's a data set that kind of challenge the model to pick the right answer by adding adverse answers for the model, try to fool the model to pick the wrong answer. This is what they mean by adversarial generations here. And also longer context, harder ending is like, it's so ambiguous that all of these can happen. All of these answers can actually happen. It doesn't mean that it would not happen at all. For some really, really odd chance, the answer A can happen, but most likely not. Longer context means the sequence of words are longer. Therefore, it's more challenging for the model to understand and probably leads to difficulty choosing the right answer. So this is kind of data set. How it works is the model, the LLM, will be given a situation. For example, the situation is a woman is outside with a bucket and a dog. Dog is running around trying to avoid a bath. Well, human will know that the woman is trying to give the dog a bath, and she needs to do something so that the dog will be bathed, right? So the right answer is C. She needs to get the dog wet, but the dog is trying to escape, right? So it runs away. This is the most likely answer. If human reads it, human would pick this answer, but the rest is just very unlikely. So this is very difficult for models probably like 1 or 2 years ago. But for now, the GPT and the Gemini models are kind of getting better at that, getting better. Like 95% is probably consider this as a solved problem at the moment. But you can see here that this is some kind of the challenge that the LLM needs to go through in order to exhibit reasoning engine. Now, before I show you the actual use case, I want to give some background about reasoning skills. This is from me reading off the internet and trying to summarize what I've learned. I thought there are 3 types of reasoning. The first one is induction. Induction is like you have observed something, you have some samples, and you are trying to make generalization statement as a conclusion. This is induction, right? So it's going from small set, and then you create rules to cover the larger set. For example, you observe that the sun has risen every day in your life on the east. You probably conclude that the next day and the days, so many days after that, the sun will rise every day in the east. But this is generalization. There's no backup that the sun will still rise tomorrow. It could happen that it suddenly blows up and, there is no sunrise anymore. So this is induction. Small set to a bigger application or generalization. The second one is called deduction. Deduction is when you're trying to make a conclusion based on a premise. You have a premise, or you are given a premise that this is true, what can you derive? You derive conclusions based on your premise. For example, the premise 1, humans are mortal. Premise 2, you're given that Socrates is mortal. Oh, sorry, Socrates is human. So with these two premises, you conclude that Socrates is mortal. That's it. The situation is that you are given a premise, a bigger picture, or a ruler, and then you need to go conclude that with that logic. The third one, abduction. Abduction is, according to this, is that it's when you are finding a conclusion that's based on a logical derivation by the best explanation that you can do with your limited information or limited knowledge. An example that probably give you a clearer illustration is that your car won't start in the morning. So based on your knowledge of the car and maybe previous experience with your car, or maybe your friend's experience with not working car, you can hypothesize, you can conclude, or maybe assume that the battery is dead. Now you identify the plausible reason for the car not working. So this is abduction, best explanation within the limited knowledge and information. To my knowledge, induction is more like creativity. LLM is pretty good at that too, but I'm probably not going to use LLM for induction. I don't want it to say something like, okay, the sun will rise tomorrow, for example. I don't think this is what I'm going to use it for. But what I'm going to use the LLM for is deduction and abduction. Deduction, again, is you have a premise and you are deriving the conclusion from the given premise. This is math and physics. All the science, we have premise or theory or theorem, whatever it is, it's a premise, and then you derive everything there. So if you want the LLM to do math, deduction capability, you can use it. Abduction is useful as well. Given the situation of the car not working, you can ask the LLM, what can happen to my car? It doesn't work. The LLM has limited information. It has limited knowledge based on the training set that it has. So it should be able to do some abductive reasoning for you. So this is a type of the reasoning. And well, I went ahead to explain this. So in real life, the reasoning tasks that I think I will probably use a lot, and you will probably use a lot as well, is math. In your business, you probably have a lot of math, right? A lot of math. Profit is income minus expense. It could be something else, maybe like risk analysis, cash flow projection, or even like conversion rate or click-through rate. If you are doing some e-commerce or website, they are mathematical calculation, and you can use LLM to help it with you. Programming, for those of you who have dealt a lot with automation or writing codes, or computer simulation, even plotting charts like sales charts, bar charts, whatever it is. I think this is deductive reasoning as well, and the LLM is actually pretty good at this. Pretty good at this. The last two are actually examples of abductive reasoning, like identifying cause to my problem, like car didn't start, what can go wrong? I'm writing my blog post. I can ask it, okay, what is wrong with my article? Maybe grammar, maybe punctuation is missing. Help me find it, finding the cause. That is not something not working. Or troubleshooting, right? You can ask it for, okay, help me correct my Excel formula. I want to do blah, blah, blah. Tell me how to do it. I didn't get it right. Or my click-through rate is not so good with my product offering on my e-commerce website. What can I do? How can I fix it? So this is a type of reasoning tasks that the LLM can actually help you do stuff. Well, now is an example that I want to show you that the LLM can help as well. Let's assume that I want to kind of like engage my customers who is probably going to be a general public. What I want to do is I will go to a festival. I set up a booth, and I will hold a lottery game. The player, general public, I mean, can pay to play, maybe like $1 to spin this lottery wheel. So I want to know, if I do this, am I going to make money? And what's the chance of me losing money if I am doing this spinning wheel thing? So there are factors I can think about. Okay, if I create a spinning wheels, how many wedges do I need to make in the wheel? What are my price mechanics, like how many tiers, and for each tier, how many wedges they get? The top price should have one for sure. And what's the price, like monetary value for that, for each price? How should it be? And if I want to, well, probably need to pay the festival for having a booth there, and so on. How am I making sure that I can make money? This is math. You can go with your gut feeling for sure. Like, there are ways to do it. You can go with your gut feeling. You think you have done this before. You have heard that people have done this before and it works. It doesn't lose money. Go for it. Or you can use math skills of people, which probably not that easy to find, to be honest. The last thing is, now you have the LLM math to help you. So I'm going to skip the gut feeling part for sure. I will do two things: the people math and the LLM math. For the people math, relies on my expertise of math on statistics and probability, and we will compare with how the LLM is doing. All right, let's get started. But before I go, this is a thing that we need to set up. We need to set up rules for the gameplay, right? This is some kind of parameters that I decided for now to start with. Players spend $1 to spin the wheel, and there's only one gold prize, which the player who wins will get. This gold prize will get $10. There are two silver prizes, each is $4, and 4 copper prizes, each with $1. So this is my initial setup. Okay, let's go and take a look of how this is doing. I decided to use Google products for this. So again, I have put in some parameters. A price to pay is $1. We are getting $1 because people are paying us to play. And this is an assumption. All the wedges in the wheel, there are 30 of them. But using Google Sheet, I can change it to whatever I want. But let's start with 30. And according to my setup, gold price is 1. Silver has 2 wedges. Copper has 4 wedges and $1. And the rest is probably you can calculate it. It's 30 minus 1, 4, 1, 3, and 7. So 23 with no prices. This one use a formula to calculate that, so it will update when I change things. Okay, now these are price associated with the monetary value associated with these price tiers. Using probability, so if a person spin, there is chance that it will, or he or she will get the gold price. The chance is calculated by 1 divided by 30. For silver is 2 divided by 30, and so on. So I use a formula here. You can see that it's this divided by that. I'm not going to explain the theory of probability, but this is how it's doing. The probability of landing for each tier is calculated like that. So now, before I going to calculate the expected value, the technical term again, of people winning or how much it costs, I need to calculate the actual cost. The actual cost, why is this, is that people have to pay me $1. If they win 10, I'm losing 10 minus 1. So I'm losing $9. So it's my cost if people actually get this price, right? For silver, it's 4 minus 3. So 4 minus 1, so it's 3, and so on. So this is a cost that will be realized by me if actually the people actually win the prize. Now, according to statistics, the expectation value actually means if you are doing the experiment for a very long time, and in this case, if you have like millions or 10 million people playing, this is the cost that you are paying for the people to pay. This is the cost that I spend for people playing, right? If people are going to play and then win gold, I need to spend 30 cents for him per person. For silver is 20 cents per person. For copper, I don't care. I don't lose anything. But for a bummer, so people who don't actually win anything, I'm gaining 77 cents per play. So the actual formula is this: the actual cost multiplied by landing, and then I sum up everything here. Why do I sum it up? Because in any case, there are 4 possibilities, right? People get gold, people get player gets gold, player gets silver, player gets copper, and the last one, players get nothing. They are independent, and I have to sum this up. So when I sum it up, it gives me minus 0.27. Again, minus mean I gain. So technically, per person, I am about to gain 27 cents per player. This means that I'm winning in the long term. I'm winning in the long term because I'm gaining about 0.27 per person. But it doesn't mean that I get this everyone it comes, right? For the let's imagine that person's 1 comes in and play. He gets 10 gold prize. I'm losing already. I need to pay him 10, but I get $1 back. It means I'm losing $9. And if for some reason I cannot hold my game anymore, I stopped it. Oh God, I lost $9. But I can, if I keep going, 10 people, 30 people, 100, 1,000, a million, I will tend to make money. This is what the value is. Okay, but that's not the end. You don't know if you are actually going to make money just yet. As I just mentioned, if it happens that there is only 1 player, you can lose. You can lose money again, right? Now it's getting difficult. If I want to say that, okay, I am setting up a booth for 1 day, and I expect to have about 100 players or 100 customers. With 100 customers, can I make money? You can do it in Excel, but it's crazy difficult. This is difficult because the winning structure, the award structure is very it's not easy to do. So we'll get into this question later, but let's see if the LLM can do this part. Can it give me the expectation value of the expectation of value of cost that I expect to pay or to gain. First, I need a prompt, right? I have already made a prompt to get it handy. So this is my prompt to the large language model. I explained the game to the model. Here's a game. A player pays $1 to play the game, which is a spinning lottery wheel. A wheel has a total of 30 equal wedges. The following is a table that explains wedges for their counts and price. Wedge type, the columns of the table, there are wedge type, counts, and price. For gold type or gold tier, there's only one, and the price is $10. $10. So silver has two prices, and each is $4. For copper, there are four price. For prices, each one is $1, and the others is the rest. I want to know if the LLM can fill in the gap too. I don't want to calculate it myself. If I'm a human, I know that right away it's 30 minus 1 minus 2 minus 4 is 23 that we saw there. I want to know if the LLM can do this part or not. Now, I give it a condition, helping it. Using knowledge in statistics and probability, what is the expected value of the cost that we incur to the game owner, me, per player? And I ended up with, let's think step by step. This is a technique called chain of thought. It actually nudged the LLM to think out loud to get to the answer, and it actually helps to get to the right answer. All right, let's go with Gemini here, gemini.google.com. Start a new chat. I put in my prompt right there. Let me just increase the size. Okay, moment of truth. It's less than 4 seconds. I'm pretty happy with the result. The speed I meant. All right, what it's saying. Sure, let's calculate the expected cost of the game owner incurs per player. The expected value of an event. Okay, it's explaining blah blah blah. The reasoning from the study of statistics and probability. But now it's doing the steps. Define the cost for each outcome. Okay, it knows the cost. Well, I put it in the table. At least it understands the table correctly. Calculate the probability of each outcome. It's actually pretty good. Look at that. Gold, the probability of having gold price out is 1/30. So it's 1/30 probability. 1/30 is here, 3.33%. Does it match to my Excel sheet? Right on. 3.33 and so on. 2 is okay, that's good. 2 and copper. And look at that, others, 23 wedges. It knows how to calculate that value, right? Pretty good. Now, the third step, consider the expected cost for each outcome. Okay, saying that we multiply $10 with the probability. We have this value and kind of say that, do the rest for all outcomes, and then we sum it up. Oops, my bad. Let's continue. We'll sum it up for expected value. Okay, it's doing that. 10 multiplied by 1/30. Here comes for the silver price, the copper, and the other price. There you go. This is the cost. Therefore, the expected cost you incur per player is this. Oh, do you think it's correct? It's missing something, you know? It's actually missing the this one is missing that I'm gaining $1 per play. So if we actually forget about that, can we? Actually not right? There's something wrong there. I'm not quite believing this yet. Okay, let's compete. I'm going to ChatGPT 4. Right here, ChatGPT 4, giving it the same prompt and see how it's doing. Wow, it kind of answered right away. Like really right away. Okay, probability for gold 130, 230 for silver, copper is 430. Actually doing pretty good. It's analyzing. Okay, this is a pretty cool feature of the GPT-4. It's actually using agents. It's actually calculating the actual values from calculator rather than from the LLM itself. Look, so the expected payout per spin is 73 cents. But eventually, because we gain $1, therefore we have to subtract from $1. So the expected cost that will incur to the game owner per player is approximately 27 cents. This is actually what we found. Look, I don't know what's happening with Gemini. Maybe it doesn't understand us properly. This is like way wrong. So sorry, Gemini, you lost again. ChatGPT correctly calculate the value of this problem. Now, I'm going to ask it a more difficult question. I want to ask, if we have 100 players, what's the chance of not losing money if we are actually need to pay rent for the booth as well for $50? Let's do this. So it's explaining that. Okay, while it's analyzing stuff, this is a difficult problem because we can't really apply statistical models right away. If we only have one price, let's say gold price, and the rest is no price at all, we can apply what we call a binomial distribution to this situation, and there are closed form formulas that allows you to do this. But since we have 3 award tiers, we need to do simulation. What I mean is that we create, artificially create 10 players, and we roll the dice if this player is winning or not. Each of them. And some of them will win gold, some of them will win silver, we don't know. And we actually calculate the money we lose and we gain from that set of 100 players. And we actually do this set of 100 players so many times, and then we will eventually see the distribution of the money that we get and the money we lose. And this is what they are doing, right? So it's saying that we need to do some calculation. Expected earnings, blah, blah, blah. Total, okay. Actually, this, wow, this is not the answer that I expected. Actually, do what we call, okay. Okay, this is unexpected. Admittedly, I tried this yesterday and it actually made the Monte Carlo simulation, which is the situation that I just described to you. Here, it simulate 100 spinning wheels and then calculate the total payout and then see the distribution of this total payout. And then it says that this is doing right based on the Monte Carlo simulation for 1,000 sets. And including that we are needing to pay rent to the festival owners, I guess, festival organizer, we have a chance of about 12% that we are actually losing money, meaning that we don't make money enough from the game to pay the rent. And this is the code that ChatGPT helps create Python code so that you can actually run this. You can actually modify this to a different reward structure. Here you can change number. Okay, if you know that, okay, this your festival day, you will have probably 10,000 people coming, and you can attract at least 1,000 people. You can change this number. You can copy this code and go to your Python editor like Jupyter Notebook and whatever. You can edit this code and you calculate the probability. So yeah, I think this is really helpful. I'm not sure how this answer came about, but I'm not trusting it. I know by my gut that this calculation is not that not that easy to just use the expected value just yet. But I'm glad it happened. So I can tell you that there's such a thing called Monte Carlo simulation. If you're not sure about the LLM capability, ask it to do Monte Carlo simulation for your probabilistic problem. All right, you're lucky today. The problem happened. Okay, back to what we were before I jump into this example here. What we were is that the LLM has reasoning abilities that can help you do your business in real life, especially math, programming, identifying causes, and troubleshooting. You can ask it to do difficult situation that, as an example, is this probability game. All right, that comes to the end of our live episode today. What we have covered so far is OpenAI's new text-to-video generation model, SORA, and honestly, I really like it. I am excited for it to be publicly available. We have also talked about LLM as a reasoning engine, and we picked Gemini and GPT to do that. Thumbs up. Yeah, a little bit. GPT is still winning, and the reasoning tasks in real life, you have seen there are probably four of them, and I think you can use it in your business and in your life. So that comes to our conclusion. I'm very happy for you to come to us to be with us today. I hope you will learn quite a few things on how to use AI and how the AI technology and advancement has gone through. And don't forget to follow our channel, Case Done by AI. You can find us on Facebook, LinkedIn, and YouTube. And we promise that we'll bring you more information, and probably useful and exciting information about AI and generative AI in general, so that you can live better, you can work better, you can make your business organizations better, especially when if you are an entrepreneur or a manager or chief technology officer. I'm signing off. Bye bye.